NASA is well known for its space exploration and discovery. The agency, however, is also making discoveries beneath the Earth right here on the globe. One such example is a bizarre new discovery beneath Antarctica's ice that has changed scientists' perceptions of the planet. What exactly has NASA discovered? Is it affecting you? Hello there everyone, welcome back to our channel. In today's video, we'll discuss whether the secrets of Antarctica are finally out. Will they change everything? To receive notifications every time we release a new video, you must first subscribe to our channel and click the bell symbol. Let's get started right away. Few individuals consider Antarctica to be a dream vacation, which is understandable. Antarctica is the world's fifth largest continent, with an area of approximately 5.4 million square miles, 14 million square kilometers. The continent's size, however, varies with the seasons, with increasing sea ice around the coast roughly doubling the continent's size in the winter. Almost the entire Antarctic continent is covered in ice. In fact, less than half of the vast wilderness is ice-free. This location has 90% of the world's ice in an area slightly less than 1.5 times the size of the United States. The temperature is so low that if you toss boiling water in the air, it'll rapidly vaporize because the majority of the particles will turn into steam while the remainder will constantly turn into small bits of ice. East and West Antarctica are the two regions of the continent. East Antarctica is roughly the size of Australia and makes up 2/3 of the continent. The ice in this section of the continent is 1.2 miles or 2 kilometers thick on average. West Antarctica is a chain of ice islands that stretches all the way to South America's southernmost tip, forming an extension of the Andes Mountains. The Transantarctic Mountains, which span across the continent and are occasionally entirely covered in ice, separate the two zones. Is it possible to find plant life in Antarctica? In a way. It consists of only a few mosses, lichens and algae. Seasonal moss cover on Antarctica has steadily risen over the last 50 years. Despite the absence of amphibians, reptiles, and terrestrial mammals, animal life is far more widespread. During the summer, enormous numbers of pigeons, whales, fish, and invertebrates thrive along Antarctica's shores and cold seas. What about human life on this vast ice sheet? While there are no indigenous inhabitants in Antarctica due to the harsh weather, up to 4,000 visiting scientists can be found spread across 70 research sites in the summer, surviving the cold on the continent. During the harsher winter, that figure drops to 1,000. Antarctica is primarily a research destination for climatologists, oceanographers, and marine biologists. However, the frozen desert also draws astronomers from all over the world. This is because if you can stand the cold, Antarctica is one of the best spots on Earth for astronomical observation. This is due to its dry climate and lack of light pollution. When it comes to monitoring space, this brings NASA, the Lord of the Universe, into the picture. What exactly has NASA been up to in Antarctica? Looking down from above, the Antarctic ice sheet may appear to be a tranquil, continuous ice blanket that has covered Antarctica for millions of years. But don't be astonished if the ice sheet is thousands of meters thick at its thickest point and conceals hundreds of meltwater lakes where its base meets the continent's bedrock. Scientists have enhanced their maps of these secret lake systems beneath the West Antarctic ice sheet using the most advanced Earth-observing laser equipment NASA has ever flown in space, and have identified two additional of these active subglacial lakes called Conway and Mercer. The new research is crucial for detecting new subglacial lakes from space and determining how the secret plumbing system affects the rate at which the ice melts into the Southern Ocean, adding fresh water that may alter its circulation and habitats. Scientists were able to precisely map the subglacial lakes using NASA's Ice Cloud and Land Elevation Satellite 2 or IceSat-2. The satellite measures the ice surface's height, which, despite its massive thickness, rises and falls as lakes fill and empty beneath the ice sheet. The study, published in Geophysical Research Letters, combines height data from IceSat-2's predecessor, the original IceSat mission, and the European Space Agency's polar ice thickness monitoring satellite, Cryosat-2. For decades, the hydrology systems beneath the Antarctic ice sheet have remained a mystery. That began to change in 2007 when Helen Amanda Fricker, a glaciologist at the Scripps Institution of Oceanography at the University of California, San Diego, produced a breakthrough that helped update the classical understanding of Antarctic subglacial lakes. For the first time, using data from the initial IceSat in 2007, Fricker discovered for the first time that beneath Antarctica's fast-flowing ice streams, a complete network of lakes joins, actively filling and draining over time. Previously, it was assumed that these lakes would keep meltwater static without filling and emptying. The initial IceSat mission is credited with identifying the interconnected systems of lakes at the ice bed interface that move water around, allowing scientists to explore all of the implications of glaciology, microbiology, and oceanography. However, thanks to IceSat-2, scientists now have a sophisticated tool that produced data with such high precision that they were able to begin mapping out the lake boundaries on the surface. Subglacial water exchange in Antarctica is thought to be caused by a combination of factors, including fluctuations in the pressure exerted by the massive weight of the ice above, friction between the bed of the ice sheet and the rocks beneath, and the rising heat from the earth beneath that is insulated by the thickness of the ice. This is in sharp contrast to the Greenland ice sheet, where lakes near the glacier's bed fill with meltwater that has drained through cracks and holes on the surface. How deep do the Conway and Mercer lakes go beneath the surface? These icy treasures are concealed beneath 1.2 to 2.5 miles, that's 2 to 4 kilometers of ice on the world's southernmost continent. They fill and drain in strange cycles that may influence how quickly the ice sheet moves and how and where meltwater enters the Southern Ocean. This movement in turn has the ability to alter the currents in the Southern Ocean and so affect global ocean circulation. Unlike most lakes on the surface, which remain in the same location for years, this subsurface water system is dynamic and very fluid, pun intended. Scientists were able to follow changes in the subglacial lake system between 2003 and 2020 by merging data from various satellites. They concentrated their efforts on 3 regions with high satellite coverage and known active lakes: the Mercer and Whillans ice streams in West Antarctica, the lower McHale ice stream in West Antarctica, and the Upper Academy Glacier in East Antarctica. The researchers discovered 2 new lakes along the Mercer and Whillan boundaries, which they named the Lower Conway Subglacial Lake and the Lower Mercer Subglacial Lake. They also discovered that what had been assumed to be a single lake beneath the McHale ice stream was actually 2. These lakes have changed dramatically throughout time. For example, the lakes beneath the Mercer and Whillans ice stream boundaries have been drained at least 3 times in the last 17 years. Meanwhile, the lakes beneath the McHale ice stream have all followed their own draining and filling patterns. During the study period, the lowermost lake saw 4 fill-drain events, each of which took roughly a year to complete. The second lake drained between 2014 and 2015 and has since refilled, whereas the third lake drained only marginally between 2016 and 2017. Meanwhile, between 2009 and 2018, the lakes beneath Academy Glacier were drained. All of these changes help scientists piece together the speed and direction of Antarctica's ice sheet flow. Researchers are already discovering connections between the under-ice lakes and the ocean. According to Life Science, a study co-authored in January last year discovered that the drainage of one lake on the Amory Ice Shelf in East Antarctica discharged up to 198 billion gallons, or 750 billion liters, into the ocean in just 3 days. While it is amazing to discover lakes buried deep beneath the ice in the Antarctic, you may be wondering if there is life in that lake. On the surface, the climate is harsh enough, but can life thrive deep within the 2 freshly discovered lakes? Early investigations of water samples taken from the Lake Mercer revealed that they contained roughly 10,000 bacterial cells per milliliter, according to expedition leader John Priscu, a professor of Arctic ecology at the University of Montana. While this is just around 1% of the 1 million microbial cells per milliliter seen in open ocean, it is nonetheless an amazing find for a sunless border of water buried deep beneath the Antarctic glacier. However, the high levels of bacterial life in the dark and deeply underground lake indicate that it may host higher life forms, such as microscopic animals like tardigrades. Meanwhile, the profusion of bacterial life in Lake Mercer paralleled the discovery of high levels of bacterial life in Antarctica's nearby subglacial Lake Whillans in 2013, which Priscu also led. Scientists believe that bacteria in Lake Whillans and potentially Lake Mercer are thriving on carbon deposits left down by photosynthesizing species between 5,000 and 10,000 years ago, when the subterranean lakes were connected to the open ocean. Let us know what you think of NASA's discovery of evidence of life on Mars in the comments area below. That was the end of it. Thank you for taking the time to look at this. If you liked it, please tell your friends and subscribe to our channel for more excellent videos and up-to-date information. We look forward to seeing you in more videos in the future.